Welcome back, ladies and gentlemen, boys and girls. Thanksgiving is over.
And Christmas is right around the corner.
And it's blank. I thought you were going to finish the script.
I thought you were going to write the script.
I thought it would be fun to turn our annual gingerbread house making activity into a chemistry lesson.
This week, we're going to show you how we made sugarglass.
And how we attempted to turn it into a complete sugarglass gingerbread house. But ultimately, it turned into an episode of Nailed It.
Just like that show on Netflix.
But for the science aspect of it, to make sugarglass, you need what is called a supersaturated solution. So that's where the chemistry comes in. We're going to have some fun making some gingerbread houses. We're going to learn about supersaturated solutions and other terms that go along with it. And we're going to send 2020 off with a bang. While you watch the intro, we are going to the kitchen.
Kitchen.
Because kitchen science is the best. Me look you.
Disclaimer about our kitchen. We are currently remodeling it. While we are super happy to have countertops, cabinets, and a refrigerator, we have no microwave over the oven, no backsplash on our walls. There is exposed wire here, here, and even here. But don't worry, all of these wires have been turned off at the breaker, so they're done. Did I get you?
No.
Maybe just a little bit?
Moving on.
The great thing about dad jokes is they're always funny. So now it's time to sit down and draw our plans. And if you'll notice, we used the boogie board that I referenced in our Christmas gift list video last week. That thing is great. But as you will obviously see later in the video, I'm a homeschool dad and a doctor. I'm clearly not an architect. One of the great things about this experiment is you don't need many ingredients, and you probably already have most of them around the house. From sugar to cream of tartar.
Let the fools have their tartar sauce.
To corn syrup. And if you're feeling adventurous, you can throw in some food coloring and sprinkles for good measure. Alright, it's time to grab you a good sized cooking pot. For starters, you're going to need 3.5 cups of sugar for each batch. And good luck getting your kids to not eat the sugar. What in the wide world of sports? Okay. No more eating the sugar. Go ahead and dump your sugar in the pot. After the sugar, now it is time for 2 cups of water. Next, it's time for a cup of white corn syrup. And don't forget a 1/4 teaspoon of cream of tartar. So for this, you're going to have some pre-made molds. We had a bunch of square plastic molds we were going to use to make our walls. But what I didn't plan, and the reason I referenced me not being an architect, was how we were going to make the A-frame. So in a pinch, what we decided to do was to make our own molds out of aluminum foil. And in hindsight, that is when things were destined to not turn out great. So back to baking. I had them initially stir all the ingredients together without heat on in the pot. That way, they would understand later when we talked about supersaturated solutions why the heat was important. You see, without the heat, there's no way for that small amount of water to dissolve all of the ingredients. Okay, now for some heat. With the heat going and the candy thermometer now in place, it was time to really start cooking and making some sugar glass. The goal temperature is 300 degrees Fahrenheit. Anything less than that and you're basically just making taffy. Anything higher than that and you end up just burning your sugar. Once we hit 300 degrees, it's time to pour out our sugar glass solution. Obviously be very careful, it's very hot. We tried to get a little bit creative and go ahead and put some sprinkles down on one pan to see what that would turn out like. Once you pour it, it's also a good time to add some food coloring for different effects. Once you have it all poured, you may have to carefully lift up your molds and tilt them in all the directions so you ensure that your solution goes to all the corners and all the edges. You can see that's where I put the food coloring in. I was hoping to get just a few drops in there, but I inadvertently put half the bottle in there. Hey, I'm a scientist, not Martha Stewart. Now it's time to let our molds harden, and that whole process takes about 2 hours. While the sugar glass is hardening, that's when I do the science lesson with the kids. So if you're here just because you're interested in the sugar glass and want to see how it turns out and not terribly interested in the science part, then I would skip to this part of the video right now. If you're still here, then that's great, and that means you're interested in science. And that's basically all we do here on this channel. So before we go on, why don't you consider hitting that subscribe button down below, and we'll see you for one of our weekly videos. Don't forget our website of the same name, homeschoolscienceclub.com, oftentimes has worksheets that go along with it. So if you're a parent, you can have your kids watch the video, do the worksheet, and it's a free science lesson. We've talked about the chemistry of solutions before on our channel. It was when we did the How to Make Colossal Bubbles video over the summer. We talked about what a solution was and how it was usually composed of a solvent and a solute. If you remember, the solvent is the part of the solution that does the dissolving, and the solute is the part of the solution that is being dissolved. When you think about a solution, it's common to think about two liquids coming together to form a new substance. But you can have a metal solution like this brass being a combination of copper and zinc. Even the air we breathe is a combination of nitrogen, oxygen, and other gases to make a gaseous solution. There are other terms that we need to know when dealing with solutions. In addition to solvent, solute, there's also saturated, dilute, and supersaturated, and that's the focus of the video today. A saturated solution is defined as something that has a lot of solute in it. A dilute solution is the opposite. It has more solvent than solute. Now, dilute and saturated are inherently vague terms, and scientists have been using more specific terms like molarity and molality. Now, those are terms more for high school students, and fortunately for me, my sanity, and what hair I have left, that's still a few years away. Now, every solvent has a certain amount of solute that it can dissolve before it can't do anymore. You can think about it like a trash can. Think of the trash can as the solvent, the trash as the solute. You can put a lot of trash in a trash can, but at some point it gets full and no more trash can go in there. But if we could somehow make the trash can bigger, then all of a sudden there's room for the solute. And that's what a supersaturated solution is. You see, at the beginning when the kids were stirring the solution without the heat, the water couldn't dissolve all of the solute, or in our case, all of our ingredients. But if we can make the water bigger, and that's what the heat does. It provides the water molecules with a lot of energy, expands the water, and now there's more room to dissolve all that solute. So that's what a supersaturated solution is. It's a solution that has more solute in it than it's supposed to have at a given temperature. So in summary, a saturated solution has a lot of solute and less solvent. A dilute solution has a lot of solvent and not a lot of solute. And a supersaturated solution, like what we're making today, has way more solute than it's supposed to have because it's been heated up. Alright, let's go back and check out our results. The last thing we did before pulling out our molds was to make some glue, and that was just a combination of meringue powder, some powdered sugar, and water. We had done a pretty good job of keeping our kitchen clean, up until this point. These are all of our hardened molds, and it was at this point that I realized that I'm not an architect because we didn't even build enough to make a complete roof. But as you will soon see, it wouldn't matter anyway. Now it was time to very carefully take the tinfoil away from the sugar glass. And I say carefully because the edges can be pretty sharp. If you end up with sharp edges, all you have to do is take a wet cloth and rub the sides and it will dull the edges quite a bit. Now it is time to build our sugar glass Christmas gingerbread house. Which begs the question, is it really a gingerbread house if there's no gingerbread in it? So obviously for the sake of time we're speeding this up a little bit, but it is at this point when we realize that A-frames didn't really come out like we wanted it to. The imprecision in the molds led to poor contact between the roof and the A-frame, and they ultimately kept wanting to slide down. Part of it was the sugar glass was too heavy as well, and no matter how much glue we put on there, they were just not going to stay. So we decided we would improvise and just get some regular old gingerbread and use that as our roof. And that's when it happened. A silent earthquake came, and our house made of glass crumbled. So with that big disappointment, our attempt at making a sugar glass gingerbread house quickly transitioned to making a Christmas sugar glass barn. But what a beautiful barn it was. Complete with stained glass, walls filled with sprinkles, and a few Harry Potter Lego toys for good measure. So that's it for this week's video. We hope you enjoyed our sugar glass experiment. We hope it inspires you to do something similar in your home. Remember, if you're watching this after Christmas, it doesn't have to be a gingerbread house. You can do something similar to make regular old glass candy or lollipops. The kids will love it. This is going to be our last science video for 2020. Like most families, we're going to also be taking a holiday break. We really hope you have a Merry Christmas, a happy holiday, and we will see you next year in 2021. So that's